Hello everybody, this is Digital Blackboard by Sachin P. Nagmote. In this video, we are going to discuss the topic how to obtain matrix by inspection in nodal analysis. So let's start. So in the previous videos, we have solved some problems of mesh analysis, and in mesh analysis, we have to construct the mesh matrix. So the mesh matrices are impedance matrix, then current matrix, and then voltage matrix. So similarly, in the nodal matrix, we are having the first matrix as admittance matrix, the second matrix is voltage matrix, and the third matrix is current matrix. Now what is admittance matrix? So basically admittance is reciprocal of impedance. So admittance Y is given by Y is equal to 1 by Z, and the unit of admittance is mho. So always mho is equal to 1 upon ohm. Okay. So for example, if we are having a resistance of 2 ohm, so what will be the admittance of 2 ohm? So admittance of 2 ohm will be 1 by 2. If we are having a inductive reactance of J2 ohm, so what will be the admittance of J2 ohm? So admittance of J2 will be 1 upon J2. Similarly, if we are having a capacitive reactance of minus J2 ohm, so what will be the admittance of minus J2 ohm? So it will be 1 upon minus J2. So if we know these things, we can easily construct or obtain the matrix by inspection. So here the network is given and we have to obtain nodal matrix by inspection. So let's start. So first of all, we need to identify the number of nodes, and in the previous video we already discussed about the node. Node is a point or a junction where two or more than two elements are connected. So by this, in this particular network we are having three nodes available. So we will name it as node 1, node 2 and node 3. But one node we have to take as reference node. So we will choose this bottom node as a reference node, and the voltage of reference node is always 0. Now we are going to assign voltages at each node. So let V1 is the voltage of node number 1, V2 is the voltage of node number 2, and V3 is the voltage of node number 3. That's why V3 is a 0. V3 is 0 because it is reference node. Now we are going to construct or obtain the matrix by inspection. So first matrix is admittance matrix, second matrix is voltage matrix, and the third matrix is current matrix. The order of first matrix, that is admittance matrix, depends upon number of nodes. So as we are having two numbers of active nodes, total we are having three nodes, but out of that one node has to be chosen as reference node. So active nodes available are 2. So the order of first matrix is 2 by 2. Then order of second matrix, that is voltage matrix, is 2 by 1, and order of third matrix is also 2 by 1. Now first matrix is admittance matrix, so the entries will be y11, y12, y21 and y3, y22. Now similar to the mesh matrix, the diagonal entries are always positive summation and all the off diagonal entries are negative summation. So y11 and y22 are the diagonal entries, so it will be positive summation of admittances, and y12, y21 are off diagonal entries, so it is negative summation of admittances. So let's start with the filling of admittance matrix. So the first entry is y11. So y11 is nothing but positive summation of all the admittances connected to connected to node number 1. So for getting the admittances, first of all we will have to search for the impedances connected to node number 1. So to node number 1, three impedances are connected, that is 5 ohm, then J2 ohm and then 4 ohm. So what is the admittance of 5 ohm? So admittance of 5 ohm will be 1 by 5, and that's why it is 1 by 5. Then plus the next is 1 by 4, that is admittance of 4 ohm is 1 by 4, and that's why 1 by 5 plus 1 by 4. Next we are having J2. So what is admittance of J2? So it is 1 by J2, and that's why plus 1 by J2. So the first entry has been filled, y11, that is positive summation of all the admittances connected to node number 1. So we are having 1 by 5 plus 1 by 4 plus 1 by J2. The next entry is y12, that is negative summation of admittances common to node 1 and 2. So node 1 and node number 2, the common element is 4 ohm. So 4 ohm is the only common element which is connected between node 1 and node 2. So what is the admittance of 4 ohm? So it will be 1 by 4, and as it is off diagonal entry, the summation is negative, so it will become minus 1 by 4. So next entry, that is y12, is minus 1 by 4. Then next entry is y21. So as it is symmetrical matrix, so y12 and y21 are same. So y21 is equal to y12. It is nothing but again minus 1 by 4. Now the next entry is y22. So y22 is again diagonal element, diagonal entry, and diagonal entry is positive summation. So y22 is the positive summation of all the admittances connected to node number 2. So how many impedances? First of all, we will identify how many impedances connected to node 2. So we are having 3 impedances connected to node 2, that is 2 ohm, then minus j2 ohm, and then 4 ohm. So what is the admittance of this? So it will be 1 by 4, then 1 upon minus j2, and then 1 by 2. So summation of all these admittances is nothing but 1 by 4 plus 1 by 2, 1 by minus j2 plus 1 by 2. Okay, so this is the final entry which we are having, y22. So 1 by 4 plus 1 by minus j2 plus 1 by 2. So we filled the admittance matrix by inspection. Next matrix is voltage matrix, which is very simple. So here we have to just enter the unknown voltages. So from node number 1 we are having V1. So the first entry in the voltage matrix is V1, and the next entry is the unknown voltage of node number 2, that is V2. So next entry is V2. So we filled the voltage matrix as well. Now we have to fill the current matrix. So for current matrix, in the current matrix, the first entry will be the summation of all the current sources connected to node number 1. Now to node number 1, only one current source is connected, that is of 5 ampere. But here we have to take one care, just find out the direction of that current source. So according to direction of that current source, the 5 ampere current is incoming towards the node, that is the 5 ampere current is coming towards the node. So incoming current has to be marked as positive, and that's why the first entry is 5 only, because incoming current is positive and outgoing current is negative according to the sign convention. So 5 ampere incoming to the node number 1, so we have written here plus 5. Then the second entry is summation of current sources connected to node number 2. So only one current source is connected to node number 2, that is of 25 angle 90. And again we can observe here the current is according to the direction of that current source, the current is incoming. The current is coming towards node number 2, and that's why it is incoming current. So incoming current is nothing but positive. So again the next entries we are having, that is 25 angle 90. So here the matrix, Nodal matrix is completed. So we obtain this matrix just by inspection. Now as the matrix is available with us, but it is in the form of 1 by 5 plus 1 by 4 plus 1 by j2. So it will be very difficult for us for the calculation, and that's why we will prefer to convert these values in point. So 1 by 5 plus 1 by 4 plus 1 by j2 can be written as 0.45 minus j 0.5. Similarly minus 1 by 4 can be written as minus 0.25, then minus 1 by 4 minus 0.25, and finally 0.75 plus j 0.5. So to conversion of this original matrix in points is nothing but it is beneficial for us in the calculation. So finally we are having the matrix available by inspection for the given network. So I hope you got better understanding how to obtain matrix by inspection in nodal analysis. So please like, share and subscribe Digital Blackboard. For any query you can contact sachinnagamothe@gmail.com. Thank you very much.